Should have tested my microphone. It looks like my microphone's working though. Test. Looks like it's moving. So going back to today, dissolving salt in water. You can see my screen, right? Can somebody confirm? Anyone? Harriet?
Yes, we
All
can see
right,
your
thanks. So all this stuff I've been sharing with you about water. If we looked at the earth science proficiencies, the things I'm supposed to be teaching you this year, there's kind of a separate unit on properties of water. And I'm just covering those in the form of these warm-ups, which I'll wrap up in a few days. But water plays a big role in earth science. There's the water cycle that we've kind of been hitting on with water evaporating, going into the atmosphere, condensing, coming down as precipitation. So there's that. Um, but there are also these properties of water I've been talking about with surface tension and density. When water freezes, it expands, and then when it melts, it contracts, and that does things like not only breaks up our roads, but it also breaks up the um, rocks around the earth. And the attractions between water molecules, these little positive and negative charges on the water molecules, those are important not only because you can do things like make paper clips float on the top of water, and do this cool trick with soap, but that is what allows water to dissolve a lot of substances that are in rocks. So a lot of sediment that creates sedimentary rocks um, is formed by the breaking down of rocks, not just by rain hitting or wind blowing or freezing, causing water to expand in cracks and break them apart, but by the water molecules just going into the rock and dissolving it. A lot of things are dissolvable in water. Water is called the universal solvent. A solvent is something that can can dissolve things. So I don't know if you've ever really looked at or had teachers talk about what dissolving really means, but that's what this picture is showing over on the right. And there are a few questions that I don't know, I might ask you to answer some, but I'm going to answer most of them. The first one is, what are the red dots in the diagram? And second one's, what are the white circles? You know, I think I think one of you could probably tell me that. I will tell you that the little things that are white and red, those are water molecules. So what are the red dots? Anybody? No one? Oh, RJ, what are they? RJ,
Oh,
you.
I accidentally unmuted. Sorry.
That's okay. Now you can answer my question. So what do you think? That's the 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 things with two red dots and a white circle. Those are water molecules. So this thing that I've got my mouse on right now, that's a water molecule. There's this, and then there are the two red dots. Here's another water molecule. Another water molecule. So do you know what the red dots are?
O2.
That's a good.
2O. 2O.
So it's the two part, right? In H2O. So in H2O, it's H2. So there are two H's. So these are the H's. These are the hydrogen atoms, and then that's the oxygen atom. And let's see. I don't know if I'll put somebody on the spot. Um, Question number 3 over here. What part of a water molecule grabs sodium atoms and why? So in this picture, you wouldn't know this, but sodium, maybe some of you know it. The chemical, the abbreviation for the element sodium is Na. I don't really know why. You'd think it'd begin with an S. So that's sodium, and this over here is Cl, chlorine. That makes sense. And table salt, which is what is being represented here by the green and the gray circles, that's table salt. That's the kind of salt that we eat. I've got some here on my desk. I had pepper yesterday. Um, that's sodium chloride, which is that's what we call table salt. But the question, number 3, what part of a water molecule grabs sodium atoms? Now here they call them sodium ions. We haven't really gotten too much into chemistry. You'll do that probably in 11th grade, but the gray, that's a sodium ion, and there are two different ways to get at the answer to this question. What part of a water molecule grabs sodium atoms? So if you look at that gray that my mouse is on, can anybody tell me what part of a water molecule is going to grab that? Is it going to be the hydrogen or is it going to be the oxygen? You can tell from the picture. Nobody's wanting to participate. Okay. So if you look at the picture, all these white circles, they're next to the gray. So those are the oxygens. The oxygens are attracted to the sodium. And sodium has a positive charge. So even if we didn't already know it, if you didn't remember this, the oxygen must have a negative charge, and that's what's attracting them. So water molecules are attracted to sodium ions or sodium atoms because the negative end of the polar water molecule is attracted to the positive sodium. But over here we have some chlorine. The greens are the chlorines, and right there they've labeled it Cl negative. Chlorine ions are negative, and that's why all the water molecules that are next to the chlorines are turned around the other way. So the little red hydrogens are touching them because the hydrogens are positive. So what's happening here is over on the left, this is regular table salt, and table salt exists in what's called an ionic compound form, where we have positive sodiums sticking to negative chlorines, and they do this in this crystal structure. But if you introduce a bunch of water here, the water gets in there, and the negative oxygens start to grab these positive sodiums, and the positive hydrogens start to grab those negative chlorines, and eventually they break the structure apart until the sodium and the chlorine just floating around in the water. So I'm going to do this in my, or Bill Nye, I would say, my glass of science or something like that. Oh, come on. Got to unplug. Should start working soon. Come on, camera. There we go. So just got a glass here, and going to sprinkle some salt in there. It's kind of hard to see. Yeah, you can see it in the bottom. There's the salt. And I have some water. Now, I haven't exactly cheated. In a way, maybe I've cheated. I'm just going to use this water to dissolve the salt. Now, looking down in there, if I tip this, turn this light off. I think the glare is not helping. I don't know if you can see it. It's pretty much gone already. It just kind of dissolved itself. So let me add some more. And see if I can get it to settle over here. There. Well, come on. Can you see it now? This is terrible camera work. It's getting kind of cloudy. By the way, if you ever want to make a really dense solution, solution meaning you dissolve some sort of a substance in a liquid, and when I say dense, I mean to make stuff float well in it, I would use sugar. I've found that if I use salt, it's kind of cloudy. So if I want to dissolve that better, I can stir, and I'm mechanically separating all that salt and mixing it in with the water so the water can grab it, and now it's all gone. And what would you guess would be better for dissolving salt? Cold water or hot water? raise your little artificial hand over there if you think hot water would work better than cold water to dissolve salt. Nice. I'm getting some responses. Oh, this is exciting. So yes, all the people who've got their little fake hands raised, the hot water works better, and that's why I've got this insulated cup with really hot water in it, so it dissolves stuff well. Stirring dissolves salt well because it mixes these water molecules in with these chlorines and sodiums. And also, if the water molecules are moving around fast, then they get mixed in better. So that's how you dissolve something. So once you've fully dissolved salt in the water, it should look kind of clear. You shouldn't be able to see the salt anymore, but as I've said, it looks kind of cloudy. If you do sugar, sugar is a more complicated molecule. So I don't have any good diagrams of sugar dissolved in water. This is a lot simpler to understand what we're looking at here. But sugar makes clearer water. So if you came in late, this is just one more important property of water. Water does this not only to table salt, but to a lot of substances in rocks over time, and it shapes the earth in its dissolving action. All right, Google Meet, check-in regarding the project work time. So this isn't really a check-in because I should change that to say I need to give you instructions regarding the project. So let me go to Google Classroom and I'll show you what I just put in there. We've got the Google Meet starting climate map. Basically it says starting climate mapping project, and then there's a link here. Here's your actual assignment, which I'll get into this. It says this is due next Tuesday, but you should get it done in advance. You could if you wanted to really get on it, you could finish this whole climate map project today, and then you would have you'd have very little to work on between now and next Tuesday. You'd just have a couple of quizzes, and I don't think they'll be too bad. This project should help you with the climate mapping quiz, because going through this, you'll have to really think about what causes these climates. So the guidelines are below. I've also included my example. My example is intentionally incomplete, not really good, because I don't want people to just copy it. By tomorrow, try to at least finish your pressure belts and winds. So first, let me open the daunting rubric. This is just, it's got all kinds of stuff on it. I wouldn't even bother with the front right now. In fact, I wouldn't even bother with this sheet at all for a little while. Just I'll take you through what to do. So the front, this is how I'm going to grade it. I'm going to open up your slideshow, and I'm going to score everything on here from 0 to 3. If it's missing, you get a 0. If it's excellent and there are no significant mistakes, you get a 3. But mostly what I'm going to do is I'm going to leave everything blank unless I see a problem. So for example, slide 1, title, author, introduction. Explain what you're going to do in the rest of the slides. So if you didn't do that, if there is no slide 1, then you get a 0 and another 0 here. So you've lost 6 points out of 100 right away. And then you show the completed map. And then slide 2, pressure belts. All the pressure belts are included and correctly placed, and then you explain why the pressure belts exist in these locations. If you've done both of those things, I'll leave it alone. That means you got 3s on them. So let me show you my example. I think this is the best way to go. This is the same link that I shared with you the other day, except I've added some things to it. This slide right here, this is going to go away. This is relating to just practicing making one of these videos. So here's my my introductory slide. I guess instead of title, author, introduction, this should say Stapleton Climate Map Project Introduction. Mr. Stapleton. And I'll play this just a little bit. Now, as you can see, this is the practice quiz map. I'm just using this as an example.
This is a continent I created.
Uh-oh,
Actually,
where's my
just using this as an
Oh
example.
no.
But in this introduction, you should
Well, it looks like my video had a problem.
introduction after
It's
you've finished
either
everything
the
else,
video
after
having a
you've got your
problem
completed map,
or my
and you
computer
just
having a
show
problem
the
right now.
audience
Let's see if
what you're going to be
there
showing.
was a problem
So-
with pressure belts.
These are my pressure belts. There's, you can see the pattern of low pressure.
I think it's probably my speakers right now. Hold on for just a second. I was having some issues with speakers earlier. Oh, it's trying to use my extra screen here as my output device. All right, so let me go back and play this again. It's going to be loud, I bet.
This is a continent I created. Actually, this is a quiz. I'm just using this as an example. But in this introduction, you should do the introduction after you've finished everything else, after you've got your completed map, and you just show the audience what you're going to be showing them. So this is my continent. These are the lines of latitude. You can see it extends down south of the equator to about 15 degrees south and up to about 50 degrees north. And on this map, I've drawn in pressure belts, areas of high and low pressure, and I've drawn in winds that you can see curve. I've drawn ocean currents, red for warm water, blue for cold water. Then on the continent itself, all the green represents wet, rainy areas or maybe snowy areas. The pink is a humid area. The rainy areas are caused by, in some cases, pressure belts, in some cases, the rain shadow effect, in some cases, this thing that's called coastal wet climate, which I'll explain in a little while. The dry areas can be caused by high pressure or by the rain shadow. So as I go through this project, I'm going to start with the pressure belts and explain them, tell you why they're there, how I knew how to draw them, and then I'm going to explain the winds, and then I'm going to explain the ocean currents, and so on and so forth until I'm done. And then at the end, I'm going to summarize what I've done.
So that
This
was
is the continent I created. Actually, this is a quiz.
So that was just kind of me partly talking to you about how to do this and then partly giving you an example. I made this after I was all, well, I would envision you doing this slide after you're all done because you won't have a picture of everything until you're done. So here's my pressure belt slide. This one I actually did kind of explain things.
There's, you can see the pattern of low pressure and high pressure. And high pressure occurs in places where there's heavy sinking air. The air sinks down from the atmosphere, top of the atmosphere, between 20 and 30 degrees latitude in both hemispheres. And then these places where there's low pressure, those are places where the air is rising up into the atmosphere. So light rising air doesn't create much pressure. Heavy sinking air creates high pressure. So we've got this rising air, sinking air, rising air, sinking air, rising air pattern.
And I'll just show you one more example. This is the prevailing wind. So what I really expect you to do is first create a continent, second draw the pressure belts, third, and then make a video like this. Third, draw the winds that result from the pressure belts, and then make a video explaining how you drew the winds. Fourth, draw the ocean currents, and then make a video explaining why the ocean currents are there, and just keep going in that order because each of these things depends on the one before it. So I'll show you the prevailing winds video, and then I'm going to stop showing you videos.
These are the prevailing winds, and these winds are caused by differences in pressure. So the pressure belts, which I've already explained, are the H's and the L's, the high pressure and low pressure. The wind always blows from high pressure to low pressure. So that's why the wind in this area is going from here toward the north. In this area, the wind is going from high pressure to low pressure to low, and high to low. But it also curves because of the Coriolis effect. All of the winds north of the equator, everything that travels across the Earth's surface or maybe through the air, over the Earth, turns clockwise in the northern hemisphere. So that's why this wind, instead of just going straight north, it curves like this. So this is clockwise, and this is clockwise. In the southern hemisphere, the Coriolis effect causes things to curve counterclockwise. So these winds are counterclockwise. So to summarize, the winds go from high pressure to low, and they go clockwise in the northern hemisphere, counterclockwise in the southern.
All right, so if you look at my example, you can see I don't really have all these done. I might put some things in here. I've got a little summary that I stuck in at the end just so you can see kind of how that looks. Ocean currents, if you watch this, I've drawn some ocean currents on here, but I haven't really explained them because, again, I want you to be thinking about what we've been going over in class, maybe think about those notes that I gave you and use that to explain all these things rather than just watching my videos and copying exactly what I say. All right, let me go back to this handout. It's somewhere in here, I think. Is it not one of these things? No, it's this. So on the back of this, there are maybe some useful instructions, and I'm going to explain a little bit about what they mean right now. So design a continent that demonstrates all of the climate features we've learned about in class. Your continent must cross the equator. It must extend past 40 degrees latitude, north or south. It must be wide enough to have all the climate features, wide enough for you to show them clearly. Must have a mountain range that will cause the rain shadow effect. It must be unique in shape. It can't be exactly like something that I've already done in class. So you should have a piece of paper like this, and if you don't, you could make your own paper. And I can try to provide another link to this if somebody wants to print this out. But this is just showing different latitudes. So in designing this, doesn't really matter. It's got to either go past 40 degrees north or it's got to go past 40 degrees south, and it has to cross the equator. So the smallest continent you could make would be one like that. You could do that. It passes 40 degrees, passes the equator. That would be it. But you also, in order to have all the different climates, you're going to need some mountains, and you're going to need mountains in a place where there are winds. So you could put some mountains here, or you could put some mountains here, or you could put mountains in both places. Putting mountains in here isn't going to really do you any good because that's not going to cause a rain shadow. And putting mountains right around the equator is not going to cause a rain shadow either because those are places where you don't really have winds. You just have rising air and you have sinking air. So you could do one that's as terrible and boring looking as that, or you could do one that goes past 40 in both hemispheres. I wouldn't recommend going past about 50 degrees. So if you do, then things get complicated. We haven't done any examples that go up here around this low pressure that's at 60 degrees or around the low pressure that's at 60 degrees south. If you go past that, then your maps are going to start to look a little different than the ones we've done in class. But if you want to challenge yourself by doing that, that's fine. Just as long as you go past the equator, past 40 or past 40. You could also, here would be another simple continent you could make there. but you've got to have some mountains. And then you just do all the climate features. So let me go back to this again. So first, design it. Second, create a black and white version of your basic map. That's what I just did. This should show. Okay, you may want to make a copy of this. I don't know if you have the ability to make copies of these things, but I don't think you really need to as long as you're careful. Worst case, you could always reproduce it if you needed to do that. Recommended, before you create your videos, go through the process of mapping all your climate features. Create a rough draft. So what I mean by that is, before you do the pressure belt video and the wind video and all that, just draw all the climate features. Just go ahead and do the pressure belts and do the winds and do the ocean currents and do everything on this, and make sure it's right before you go back and make your videos for the slideshow. And the rest of this is just basically showing you what I've already shown you. It's just putting it in words. So you've used the template to create a Google slideshow. 7 of you at least have done that. I guess I should put a link to that template. I'll put a link to the template on today's assignment in just a minute. Carefully draw only your pressure belts. This is when you do the pressure belt one on your map. Make some notes relating to what causes pressure belts. So off on the side, you could have some notes you could look at as you go. You can refer to these as you talk. You could also use an extra diagram if you want. So use whatever means you want to explain these climate features. Open Screencastify, prepare to make your video, set up your computer so your map fills the screen appropriately. It shouldn't be a tiny little thing. I made mine as big as I could. I used this. I found this sitting around in here. I used this as a background. I put my map up against that. I moved my Chromebook until this was as big as possible in the Chromebook window. There was still a little bit of wasted space over here, but I made it as big as I possibly could. One thing about Screencastify is you can actually pause the video in the middle. Although these videos will be short enough that if you don't like it, if you're panicking in the middle, you can just stop it. You can delete it and make a new one. If you've got a bunch of extra stuff in your video, trim it off. And then finally insert it into your slideshow. I'll also put another video link in there showing you how to rename these videos. When you make a video in Screencastify, it'll go right into your recents folder or recents in Google Drive, and you can rename those things. I renamed mine pressure belts, winds, and that way when I went to insert them in my slideshow it was easy. So just to summarize, design your continent, make a basic map, make a rough draft, redraw it so it's blank, and then do videos of all these things one at a time. First, a pressure belt. Draw your pressure belts, make a video. Draw the winds on top of the pressure belts, make a video. Then on the same map where you've got your pressure belts and your winds, do the ocean currents, make a video. Then on that same map, add in the major desert and rainforest, make another video. And then you keep going until it's all done, and then go back and do the introduction and the summary. Does anyone have questions?
When is this due?
Due next Tuesday.
Okay.
So I'm hoping that today you could maybe get your pressure belts and winds done. But it doesn't really matter to me. But the whole thing is due next Tuesday. And this is going to be the main thing we're working on the next few days. Maybe a little more review for some quizzes, but I won't really be teaching you anything new except in the warm-ups, I guess. So I'm going to make myself some notes here of things I want to add to this. I'm going to add, I'm going to add the slides template. So I know only 7 of you have made that Google slideshow and put in your video of your video explaining coastal wet climates that I wanted you to do as an example. So the rest of you probably haven't even made a Google Slides slideshow. So this will be for you, so you can get started. Those 7 of you who did do that assignment, just keep using that same slideshow, and you can delete that slide now if you want to, because I've confirmed that you've got it. Or you can just leave it there. I can delete it later, or I could never delete it. It doesn't bother me. And then the other thing I need to do is to I've got a video that I just made a little while ago. Video of instructions for inserting videos. So I'll put a link to that and a link to the slides template, so the Google Slides template that you can make a copy of, in here, today's assignment, begin climate map project. So that's it. If you want to go ahead and start, you can go. You can sign off, leave our meet, or you can hang out here if you have more questions. I'll keep it going for a little while.